Here's a situation you've probably been in. You spend an hour or two messing around with AI prompts. Some results are genuinely impressive, some are terrible, most land somewhere in between. And when you're done, you're not actually sure whether AI helped or whether you got lucky in a few tries. That uncertainty is the real problem, not the inconsistent results. Those are expected. The problem is having no way to tell the difference between this worked and I should use it, and this worked once and I'm fooling myself. That's what this video fixes. We're going to talk about how to test AI the same way you'd test anything else worth trusting, systematically, with a clear standard for what working actually means. Think about what random AI experimentation actually produces. You try different things, you get different results, and at the end of it, you have a collection of impressions instead of conclusions. The frustrating part is that this isn't a failure of effort. People spend real time on this. The problem is that effort without structure doesn't accumulate into learning. You can put in 3 hours and walk away knowing less than when you started because you've convinced yourself something works based on the best result instead of the typical one. That's the trap, and the exit is structure, not more time. There are four specific reasons random testing fails, and they compound each other. Start with the baseline problem. If you don't know how long a task currently takes you, you can't measure whether AI actually saved time. You're comparing against a feeling, not a number. Then add undefined success. If you haven't decided what better looks like before you start, you'll evaluate results based on your mood when you review them. If it's a good day, looks promising. Frustrated? Seems useless. Same output, different verdict. Those two problems alone are enough to make your testing unreliable. But when you layer in too many variables, changing the task, the process, and the prompt all at once, you lose the ability to know what caused any result. And without being able to replicate, even a good result is just luck you can't reproduce. These aren't minor annoyances. Any one of them makes your experiment inconclusive. All four together means you've spent time learning nothing. The framework has 5 steps, and the order matters. You can't set success criteria before you've picked a task. You can't measure results honestly before you've defined what you're measuring. Each step sets up the next one. Pick one task, set your success criteria, run a controlled test, measure honestly, and decide what to do next. That's the whole system. The rest of this video is just explaining what each step actually requires, because the steps sound simple until you try to skip one. The distinction on this slide isn't just good examples versus bad examples. It's the difference between something you can actually test and something that will consume your time without ever producing a conclusion. Look at the bad column. Improve communication across the team. There's no input, no output, no way to know if it worked. You could use AI for 6 months and never be able to say whether it helped because improved communication doesn't have a finish line. Now look at that good column. Convert meeting recordings into action items. That has an input, the recording. It has an output, a list of action items. It has a quality standard you can check. Did it capture everything? That's testable. The practical rule, if you can't describe the task as AI takes X and produces Y, it's not specific enough yet. The 3 criteria here, repeatable, measurable, low risk, aren't a checklist where 2 out of 3 is fine. You need all 3 simultaneously, and here's why each one matters. Repeatable is about data volume. If you only do a task twice a month, it'll take 6 months to run 10 test instances. You don't want to wait that long for a conclusion. Measurable is about objectivity. Without a clear metric, you'll evaluate based on impression, and impressions are unreliable, as we covered in the last slide. Low risk is about permission to fail. The whole point of testing is that you might discover it doesn't work. That discovery needs to be cheap. Your first experiment should not be a task where a bad output has serious consequences. Miss any of these, and you'll either run out of patience, run out of data, or be too stressed to evaluate honestly. This step has a trap in it that catches almost everyone. The trap is evaluating success after you see the results instead of before you run the test. Here's why that's a problem. When you see an output, you instinctively form an impression. That looks pretty good. And then you work backward. You define success in a way that matches what you got, which means you'll almost always conclude it worked, whether it did or not. Defining success criteria before you test removes that bias. Gets approved without major revisions 80% of the time. That's a standard that exists independent of any specific output. The output either meets it or it doesn't. A useful test for whether your criteria are specific enough. Could someone else evaluate results using only what you wrote down without asking you any questions? If not, tighten it. The left column on this slide isn't just more professional sounding. There's a structural difference between the two sides. Good metrics are things that exist in the world independent of how you feel. Time saved is a number on a clock. Approval rate is a count. Error rate is a percentage. These don't change based on whether you're having a good week. Bad metrics are interpretations. Feels easier, looks more professional. I think people like it. These aren't measurements. They're opinions that will shift based on context. Run the same test twice when you're in different moods, and you'll get different evaluations of identical outputs. The whole point of measuring is to remove yourself from the equation. Objective metrics do that. Subjective impressions don't. Controlled is a word that sounds more complicated than it is. It just means you've set up the test so that the results are meaningful, not contaminated by variables you didn't account for. The minimum instance count matters more than people expect. 2 or 3 tests feels conclusive when you're running them, but statistically they're almost meaningless. You could run 3 tests and get 2 great results just by chance. Run 10 and the pattern becomes real. Side-by-side comparison is the other piece that gets skipped. If you only test the AI version and not the manual version, you're not measuring improvement. You're measuring absolute performance against nothing. You need the comparison to know what the numbers mean. This slide shows the clearest version of why a baseline matters, so let's actually sit with the contrast. The AI version took 7 minutes. Is that good? You genuinely cannot answer that question without a reference point. 7 minutes is excellent if the manual process took 20. It's a disappointment if the manual process took 5. The number only has meaning relative to something, and the only honest reference point is your actual current process measured before you introduce AI. This is the step people skip most often because it feels tedious. Measuring your existing process isn't exciting, but without it, everything downstream is guesswork dressed up as data. The right and wrong columns here illustrate something that seems obvious about the abstract, but breaks down constantly in practice. The wrong approach isn't wrong because it's lazy. It's wrong because it's actually impossible to learn from. If you change 4 things simultaneously and the result is different, you have no idea which of the 4 things caused it. Maybe AI helped. Maybe the new format helped. Maybe the different task was easier. You'll never know. This matters when a test fails. If you ran a single variable test and it failed, you know exactly what to change next. If you ran a multivariable test and it failed, you're starting over from scratch. Isolate variables. It's slower in the short term. It's the only approach that actually produces useful information. The documentation template looks like overhead, and it isn't. Here's the thing about memory. It's reconstructive. When you try to recall how a test went 2 weeks later, you won't remember the specifics. You'll remember your impression of the specifics. And your impression will be shaped by what happened after. If you ended up adopting the tool, you'll remember the test as mostly successful. If you abandoned it, you'll remember them as mostly failures. The template takes about 30 seconds per test. What it gives you in return is the ability to look at actual data instead of reconstructed impressions when you're making the scale, refine, stop decision. That 30 seconds is one of the highest ROI investments in the entire process. The word honestly in this step title is doing a lot of work, and it's worth unpacking. The dishonest version of measuring results isn't lying to yourself. It's cherry picking without realizing you're doing it. You run 10 tests. 3 of them are excellent, 4 are decent, 3 fail. You focus on the excellent ones because they're the most memorable and you conclude the tool works. But the tool only works excellently 30% of the time. That's not a conclusion you'd want to build a workflow around. Average performance across all instances, including the failures, is the only measurement that tells you what using this tool actually looks like on a random Tuesday. That's the number that predicts whether it helps you in practice. The two examples here look similar on the surface. Both involve AI producing a good email. The difference is what conclusion you draw from that fact. The misleading version treats the exceptional result as proof of capability, but peak performance tells you what AI can do under ideal conditions. It doesn't tell you what it does on average. The useful version looks at the pattern, 8 out of 10. That's a real number that predicts real behavior. It also tells you exactly what to expect. You'll need to review the output every time, but you'll only need to substantially rework it about 20% of the time. You can plan around that. A tool you can plan around is useful. A tool that might be great or might be terrible with no predictability is just a source of anxiety. The three-option framework here is designed to prevent the outcome that wastes the most time: indefinite uncertainty. Without a clear decision structure, most people land in a fourth state that isn't on this slide. I'm not sure yet, I'll keep testing. And then they keep testing indefinitely, never committing in either direction, which means they may never capture the value of the tool and never free themselves from the overhead of evaluating it. Scale, refine, or stop. Those are the only three outcomes. Picking one, even the wrong one, moves you forward faster than staying in limbo. Notice that all four conditions here have to be true. This isn't a majority rules situation. The fourth one, you confidently use this tomorrow without hesitation, is the honest gut check that catches the cases where the metrics technically pass, but something still feels off. Maybe the time savings are real, but the outputs require more editing than you've expected. Maybe quality is consistent, but the process is annoying enough to keep you finding reasons to skip it. If all four are true, you've found something worth building into your regular workflow. That's actually a harder standard to meet than it looks, which is why when you clear it, it means something. The two iteration limit here is the most important constraint in the entire framework, and it's the one people are the most tempted to ignore. When a test shows promise but doesn't quite work, it's easy to convince yourself that one more adjustment will get it there, and then another, and then another. 3 months later, you're still refining something that probably wasn't going to work from the start. 2 iterations is enough to determine whether the approach is fixable. If you've made 2 targeted adjustments, each one addressing a specific identified problem, and it still doesn't meet your criteria, the issue isn't your prompts. The issue is fit. Move on. There's a reframe on here that's worth internalizing. Stopping isn't failure, it's data. When a test fails, you've learned something specific and useful. The task with this approach doesn't work. That's not wasted time, that's a conclusion. And a conclusion means you can move on to the next candidate without carrying an overhead of unresolved experiment. The alternative, continuing to tinker with something that keeps failing its criteria, is the actual waste. You're spending time and attention on something that has already told you it isn't the right fit. A clean stop frees you up for the next test, which might be the one that works. These 5 mistakes are worth looking at as a single pattern rather than 5 separate items because they all come from the same place: impatience. Testing too many tasks at once, skipping the baseline, judging by the best result, giving up after one bad test, scaling before you've confirmed consistency. Every single one of these is what happens when you want a conclusion faster than the process allows. The irony is that the impatience makes the whole thing take longer. You run sloppy tests, get inconclusive results, and then either adopt something that doesn't actually help or abandon something that would have. Either way, you're back to square one. The framework is designed to be fast: 5 to 10 instances, clear criteria, one variable. That's not a slow process. Let it work. All right, this is the last video in the Making AI Make Sense series, so it's worth taking a second look at that the whole thing actually built. The first 17 videos gave you the foundation: how AI actually works at the mechanical level. Pattern completion, context windows, hallucinations, temperature, tokens. Not hype, not marketing, it's the actual mechanism. Videos 18 to 33 gave you the execution, the techniques that turn that understanding into better outputs. Prompting, examples, chain of thought, consistency, style matching, all of it. And this video gives you the third piece: independence. The ability to look at any task, run a structured test, and make an informed decision about whether AI belongs there without needing to ask anyone. That's the complete picture. You understand how it works, you know how to use it, and you have a system for figuring out where it actually helps your specific work. This is part of the Making AI Make Sense series. If you've been watching from the beginning, you've put in the work. If you're jumping in here, the full series is worth going back through. And if you need help applying any of this to your business, if you want someone to look at your actual workflows and help you figure out where AI creates real value, that's what we do at Eau Claire AI. Visit eauclaireai.com and let's have that conversation. Thanks for watching, and we'll see you in the next one.